Okay, last example here, and this one's optional. You don't need to do it, but if you'd like a bit more practice, you can. A fourth grade class is studying the environment. One of the assignments is to grow bean plants in different soils. Tommy chose to grow his bean plants in soil found outside his classroom, mixed with dryer lint. Tara chose to grow her bean plants in potting soil bought at the local nursery. Nick chose to grow his bean plants in soil from his mother's garden. No chemicals were used in the plants, only water. They were grown inside the classroom next to a large window. Each child grew 5 plants. At the end of the growing period, each plant was measured, producing the data in inches below. All right, great. So here's my data problem. Does it appear that the 3 media in which the bean plant grows produces the same height? Okay, so let's just turn that into a claim. Step 1, the 3 media, this is the original claim, the 3 media produce bean plants with the same mean height. Okay, so all of them are the same. That is mu1 equals mu2 equals mu3. Okay, well, assuming that that is true, how likely is the data that we got? But first, let's do the opposite of the original claim. This is they are not all the same. Step 3, my null hypothesis here is going to be that they are all the same. So that's the world in which I'm going to live in for the next couple minutes and see if my data seems absurdly unlikely or not. So this is going to be at least 1 mu I does not equal mu j. And of course, they're different means. Okay. Step 4, alpha equals 0.03, doesn't it? That's sort of the first time we've ever used that one. Step 5 now, I'm going to Excel. All right, but before I do, I'm going to grab my bean plants, open, save data, sure, open in Excel. Going to insert, insert, and now I'm going to take all of this, just going to copy all of this, aren't I? Just grab it all, whoops. There we go. All the way down to the p-value. Copy. Come over here. Paste. Oh boy. That's exciting. Look at that. I don't have to copy and paste so much. Or I don't have to change these. Don't need that anymore. Looks like it's working pretty well. I get some division by 0. And this thing is not correct. K should be only. So let's go ahead and, you know what? Let's just go ahead and cut those. Let's, can I do more than that? Can I delete? Oh boy. right, get out the keyboard. I'm going to need the keyboard anyway. So let's delete. There we go. Delete. There we go. And everything works. And look, there's my p-value. All right, but let's just check. All right, that's looking good. What about this? Yeah, each one of them have 5 plants. That's fine. And that right there looks, yeah, like it's doing what it should. K is 3, very good. S is covering all of that stuff there, and should be 15. All right, this is looking great. That's all what it was before. Okay, so I'm fairly comfortable with this p-value. Nice, so there it was, just with some careful copying and pasting. Let's go ahead now and take a screenshot. I do that this way, don't I? There we go. Okay, there it is. There. Copy and delete. Notability. Paste. There we are. All right, and you can see what the outcome of this is we're going to reject, not going to be able to reject, we're going to fail to reject the original claim. So F is 0.13391. So what that means is, notice that it is small. When F is small, that means that the sum of squares between, or the mean squares between, is bigger than the mean squares within. And so, no, the other way around. It's smaller. So the mean squares within is much bigger than the mean squares between. Okay, and so the p-value here is going to be 0.8776. And so my step 7, fail to reject. And now my step 8 is, what's step 8? Step 8 is going to be, there is not sufficient evidence to reject the claim that they are the same. All right, there it is. And then we'll put in, what is this, with 93% confidence, with 97% confidence. All right, great. Okay, everybody, there you are. Have a great day.